voltage just by using a multimeter, brine, coins, paper, and a foil. Are you ready, Denzel?
Yes, I'm ready. Are you ready, AC?
Yes, I'm ready. So let's get started.
For starters, we stock old peso coins with 25 cents and vinegar soap papers in between. This will create a coin battery. For the first observation, we stock 3 of each materials first, then proceeded with 5. We then use a multimeter to see if there's a difference between the voltage of the said stocks. The coin battery with 3 stacks showed 0.30 volts while the one with the 5 stacks showed 0.34 volts. This illustrates how chemical energy can be transformed into electrical energy. The higher the stack is, the higher the voltage will be. To prove this observation, we experimented with different numbers of stacks, not only using old but also new coins. Watch till the end to know more.
voltage of 0.30, which is higher compared to the results of 5 stacks of volts.
After adding 2 more battery cells, which totals to 7 stacks of 1 peso coin, a paper, and 1 centavo coin, the result from the multimeter showed a reading of 0.4 volts. That is significantly higher than previous readings. This observation supports that stacking more battery cells will produce a higher voltage.
Hi! In conclusion, our experiment successfully demonstrated the creation of a coin battery using old and new coins, vinegar and salt soaked papers, and 25-cent coins. This setup effectively converted chemical energy into electrical energy. The old 1 peso is made out of nickel-plated steel, wherein the 5 peso is made out of nickel brass. Voltage readings from the multimeter showed an incremental increase in the number of stacked layers. 0.34 3 stacks, 0.34 for 5 stacks, 0.38 for 7 stacks, and 0.40 volts for 10 stacks, using the old 1 and 5 peso coins. This consistent rise in voltage with additional layers confirms that increasing the number of layers enhances the electrical output. Further tests with various quantities of stacks and different coin types consistently supported this observation.
We discovered that the voltage generated by a stack of nickel-plated steel coins, including 1 peso and 25 cents coins, decreases as the number of coin stacks increases. The data shows that the voltage output decreases as the number of coin stacks increases from 3 to 5. This decrease continues as the number of coin stacks reaches 7, with a significant drop in voltage output from 0.17 volts to 0.4 volts. Interestingly, the data also indicates that when the number of coin stacks decreases from 9 to 7, the voltage output actually increases. This suggests that there may be an optional number of coin stacks that maximize the voltage output. The decrease in voltage output as the number of coin stacks increases can be attributed to various factors, including material properties, magnetic interaction, and surface roughness. As the stack grows, the physical contact between the coins and the electrode may become less efficient, leading to a reduction in voltage output.
Kahit sandali lang, basta